Today we're going to look at parametric equations. So parametric equations are parametric curves. The graph of the ordered pairs of x, y, where x of t equals f of t and y of t equals g of t, are functions defined on an interval I of t values is a parametric curve. The equations are parametric equations for the curve. The variable t is a parameter, and I is the parameter interval. What this is saying right here is that we are taking our x values as a function of time, and it's creating its own function. And we are taking our y values as a function of time, and it is creating a different function, right? And so we had watched this Khan Academy video a week ago, and that's what we're doing, is we're taking our normal xy equations and we're splitting them up and seeing what is happening left and right over time and what is happening up and down over time. So in our first example, we're going to rewrite the parametric equation as a Cartesian equation by building an xy table. And then we're going to graph our equation. So I'm going to start by taking time of -3 and plugging it in to x of t to get our x value. So that would be x of -3 is equal to 2 times -3 minus 1, which is equal to, let's see, -6 minus 1, which is -7. And I'm going to do the same thing with my y of t. So I'm going to plug in -3 for t, and that gives me 5 times -3, which is -15. So these two equations give me the one xy point that when time is -3, x is -7, and y is -15. I'm going to do this again now when time is -2. I have x of -2 is equal to 2 times -2 minus 1. So that would be -4 minus 1, which is -5. And then I'm also going to plug it in for y of t. So y of -2 is equal to 5 times -2, which is -10. So I get the point -5, -10. So I want you guys to go ahead and finish filling in this chart. I did not want to waste a whole bunch of time on this video having you guys watch me fill it in, so I filled it in. You guys can pause the video right here and fill in the chart, or you can take a screenshot and fill it in later, however you guys would like to do that. But I filled in the rest of the chart with that same method. Now that we have all of these xy points, we can figure out the Cartesian line, or our normal line to that our parametric equation has created. So I can pick any 2 points I want. For me, I'm going to pick these 2 points right here, because for me, they're the easiest ones to work with. You are welcome to pick any 2 points you want. You should end up with the same answer that I do. So the first thing I'm going to do to find the equation of my line is I need to find slope. So that slope is the change in y, which would be 5 minus 0, over the change in x, which would be 1 minus a -1. So my slope is going to be 5 over 2. Now I don't know if you guys remember point slope form, but you should. Point slope form is y minus y1 is equal to your slope times x minus x1. So I'm just going to pick my easiest value, this one here with the 0 in it, and plug it in. So that would be y minus 0 is equal to 5/2 x minus a -1. So that leaves me with y equals 5/2 I'm going to distribute this 5 halves. So 5 halves x, this double negative would be a plus 1, and 5 halves times a positive 1 is just 5 halves. And so this would be my Cartesian equation. Now we want to take a Cartesian equation and turn it into a parametric equation. And they call that parametrizing, or parametrize this Cartesian equation. So they give you the option, you can either set x of t equal to t or y of t equal to t. I always set x of t equal to t. It usually tends to be the easiest. The only time that you would do the other way is if the y equation is easier to solve for t. So I'm going to say that I'm going to call x of t is equal to time. And what that really means, right, we don't usually write it x of t, we would just say x is equal to t. So that means when I come over here to my y equation, right, every place I see an x, I'm going to plug in t. So y of t, right, is equal to 3t squared plus 3. And that's it. Those are my two Cartesian, my parameterized equations. So there you go. That's it. That is all there is to it. To prove my point and how easy it is, let's do one more example. I'm going to start out the same way. I'm going to make x of t equal to t, right? So I'm going to start out with x of t is equal to t, which remembers that's just another way of saying x is equal to t. So now I come back to my y equation, and every place I see an x, I'm going to plug in t. So I have y of t is equal to 3 sine of t minus 2. And that's it. Those are my two answers. My y of t and my x of t. So yes, it does have to be a little bit more complicated, but not much. So in this case, now we're going backwards. We have the parametric equation, and we need to go back and write it as one Cartesian equation. So I'm going to start with my x equation, and I'm going to solve this for, right, I'm going to solve this one for t. So this really just means x equals 6 minus 3t. And I'm going to solve this for t. So the first thing I'm going to do is subtract 6 from both sides. And then I'm going to divide both sides by negative 3. So I have a negative 1/3 x plus 2 is equal to t. Now I'm going to take my y equation, right? We have y of t is equal to 10 minus t. And what I'm going to do is every place that I see a t, I am going to plug in, instead of t, I'm going to plug in what t is equal to. I'm going to plug that in right there for t. So instead of t, I am plugging in, oops, forgot to change, I thought I'd hit enter. Instead of t, I am plugging in negative 1/3 x plus 2. Which now means I have 10 minus, instead of t, right, we are plugging in negative 1/3 x plus 2. So I've now changed this. We are now no longer a function of time. We are a function of x. And that gives me, let's see, the double negative gives me 10 plus 1/3 x. And if I distribute the negative, it gives me minus 2. So that my final equation is y of x is equal to 1/3 x plus 8. And that is my final answer. Now, of course, we have to bring in everything we've learned. So we are going to use parametric equations with e's in them. But it still works the same way. I am still going to take my x1 and I'm going to solve it for t. And if I want to solve this for t, how do I get rid of e? I have to take the natural log of both sides of my equation. So once I take the natural log of both sides, that leaves me with the natural log of x is equal to negative 2t, right? Because remember, the natural log and e undo each other. And then I divide both sides by negative 2. The natural log of x divided by negative 2 is equal to t. Now, because I know where this is going and I want to make life easier, I'm going to do some simplification over here. This is a perfectly good place to stop, but I'm going to simplify here because it's going to make it life easier later. I can rewrite this as a negative 1/2 natural log of x, and I'm going to rewrite it that way. So now when I go to use my y equation, right, y of t is equal to 2e to the negative t. Instead of t, I'm now plugging in, right, a negative 1/2 natural log of x. So I have y of negative 1/2. Sorry, I meant to change colors. There we go. Negative 1/2 natural log of x is equal to 2e to the negative, and this is where I'm going to plug in my negative 1/2 natural log of x. So that now y of x is equal to, see, the double negative cancels out and becomes positive. And remember our rules, we can take this, what's multiplied up in front, and we can turn it into an exponent, right? So I have 2e to the natural log of x to the 1/2 power. And remember what happens with e and natural log? They undo each other. So that leaves me with 2x to the 1/2. And we know that x to the 1/2 is the same thing as the square root of x. So that leaves me with 2 square root of x. And that is my final answer. Now let's see if we remember our log rules. Starting off the same place with my x equation and solving it for t. So x equals to log of 2t. And what I need to remember is that if nothing is written there, it's assumed, or it's standard, that this is log base 10. Right? So if nothing's there, it's log base 10. And I'm going to change this to exponential form. So remember, you take this over and it bumps it up. So we get 10 to the x is equal to 2t. And this is just changing from log form to exponential form. And then I'm going to divide by 2. So I'm going to put my 1/2 out in front to make sure that nobody thinks that you can divide that 10 by 2, right? Because order of operations says that we have to do exponents first. So I cannot simplify this to be 5 to the x. I would not get the same answer. Order of operations says you have to do exponents and then multiplication and division. So this is as simple as I can make t. So now I'm ready to move over to y. So that y of t is equal to the square root of t minus 1. And remember, instead of t, I'm going to be plugging in 1/2 of 10 to the x See, it'd be even better if those were in purple. There we go. And so every time I see t now, I am plugging in 1/2 10 to the x minus 1. And this one, there really isn't any simplification. So my final answer is just that. It is just 1/2 10 to the x minus 1. And that's it. That one is done. Last one. And the only one that we actually do differently. So in this case, I'm going to take each one of my x's and my y's, and I'm going to solve each one of them for t. So I'm going to take my x of t equation, which is x equals 3 sine of t, and I'm going to solve it for sine of t. So that I get x over 3 is equal to sine of t. And I'm going to take my y equation, which equals 6 cosine of t, and I'm going to solve it for cosine of t. So that would be y over 6 is equal to cosine of t. Now, here's the fun part. I am going to remember my Pythagorean identity, right? You guys remember that sine squared plus cosine squared is equal to 1. You guys all remember that identity? So I am going to remember that and use that and then plug in for sine of t and cosine of t. So that for sine of t, I can plug in x divided by 3, and remember that's squared. And for cosine, I can plug in y divided by 6 squared, and that still equals 1. So I'm going to square out both of my fractions, so I get x squared over 9 is equal, not equals 2, plus y squared over 36 is equal to 1. Now, that's it. I'm done. Some of you guys may recognize this, that is the equation of an ellipse. So we haven't studied it yet. A lot of places will cover it in Algebra 2. We will get to it in Chapter 10. So in Chapter 10, we will deal with graphing with ellipses. But this is the equation of an ellipse. Whew! Finally, last example. We need to parametrize the line from -1, 5 to 2, 3 so that the line is at -1, 5 at the time equals 0, and it's at the point 2, 3 when time equals 1. So we need to split our x and y's and both do them as functions of time. So in order to do that, the first thing I'm going to do is I'm going to find my points for x of t, right, for my x of t equation. And remember, when I'm doing x of t equations, I'm looking at points that are t comma x, right? Time is going along the horizontal axis, and x is going along the vertical axis. so that when I look at these points, when time is 0, x is -1. So that is where my point where I get 0, -5. And when time is 1, x is 2. So that gives me a second point of when time is 1, x is 2. So once I have points, the next thing to find the equation of a line is to get slope, right? So the next thing I'm going to do is find slope. So the change in rise, which would be 2 minus the -1, and 1 minus 0. So I get 3 over 1, which is 3. And then once again, I'm going to look at, sorry, I wanted to add in there, right? So in this case, my slope is the change in x over the change in t. That's my slope this time. I'm going to put these into point slope form. So I have x of t minus minus a -1 is equal to my slope, which is 3 times t minus 0. Right? Take that for a minute, because remember, the x of t is like my y values. So that gives me x of t plus 1 is equal to 3t, or in other words, x of t is equal to 3t minus 1. So that is what is happening to my x values over time. I need to do the same thing for my y values. Right? So the points for y of t are going to be different. Right? Points for y of t. So now we're doing time according to y. So this time, when time is 0, y is 5. So it gives me the point 0, 5. And when time is 1, y is 3. So my second point when time is 1, y is 3. This time, to find slope, right, it's the change in y over the change in time. So my change in y is going to be 3 minus 5 all over my change in time, which is 1 minus 0. So that would give me -2 over 1, which is a slope of -2. And then once again, I'm going to use point slope form, but this time it's in terms of y of t minus, I'm picking this value here because it has a 0 in it, minus 5 is equal to my slope, which is -2, times t plus 0, or sorry, t, I should be consistent. T minus 0. So that gives me y of t minus 5 is equal to -2t, or in other words, y of t is equal to -2t plus 5. And I am done. Those are my two answers. Here is my x of t value, and here's my y of t value. So those are my two parametric, that is the parametrization of the line. Yay, we are finally done. So there's your homework. I've cut out number 35 and 37 because they're the backwards form, and I decided that I didn't want to go that in depth into parametric equations. So good luck and have a great day.